Unitree G1 has captured global attention not because of exaggerated promises or futuristic storytelling, but because it represents a visible shift in how far humanoid robotics has actually come. And to understand why this robot is being discussed as possibly the most advanced of its kind, we need to look at the real limitations that have held humanoid robots back for decades, where most projects struggled with balance, slow movement, fragile mechanics, and dependence on controlled laboratory conditions. Yet Unitree G1 challenges these long-standing barriers by demonstrating stable, fast, and repeatable human-like motion in open environments, something that was once considered one of the hardest problems in robotics. And what makes this particularly significant is that Unitree is not a newcomer, chasing hype, but a company with years of experience in legged robotics, especially quadruped robots, which allowed them to transfer deep knowledge of balance control, actuator efficiency, and real-time motion planning into a humanoid platform, resulting in a machine that does not move cautiously like earlier humanoids, but instead walks, turns, and stabilizes itself with confidence. And this is exactly what made its videos go viral across social media, because people were not watching a staged demo, but a robot operating in spaces that resemble the real world, moving among humans without constant support systems. And the core of Unitree G1's advancement lies in its motion control architecture, where high-torque electric actuators, precise joint feedback, and fast control loops work together to keep the robot upright even during sudden movements or external disturbances, which is why it can recover balance quickly instead of freezing or falling. And this capability alone places it ahead of many well-known humanoid projects that still rely on slow, exaggerated motions to remain stable. But physical movement is only part of the story, because the design philosophy behind Unitree G1 is equally important, as it prioritizes mechanical efficiency, lightweight structure, and cost-conscious engineering rather than building an overly complex showcase prototype. And this approach makes the robot not only impressive but also scalable, suggesting that it is intended for real deployment rather than just demonstrations. And when people ask whether Unitree G1 is truly the most advanced humanoid robot, the answer depends on how advancement is defined. Because if intelligence is the primary metric, then it is important to clarify that G1 is not an artificial general intelligence system and does not think, reason, or understand the world like a human. But robotics has never progressed by solving intelligence first, as history shows that physical interaction with the environment must be mastered before higher-level autonomy becomes practical. And in that historical context, Unitree G1 represents a critical milestone because it proves that humanoid bodies can now move efficiently and reliably enough to justify further investment in cognitive systems. And this is where comparisons with robots like Tesla Optimus often arise, as Optimus is backed by massive AI ambition, but remains relatively limited in publicly demonstrated mobility, while Unitree G1 focuses on what can be proven today rather than what might exist tomorrow. And another reason for its rapid popularity is transparency, because Unitree allows the robot to be seen walking, standing, and interacting without excessive editing or cinematic illusion, which builds credibility among engineers and the general public alike. And beyond virality, there is a deeper implication, because robots like Unitree G1 hint at a future where humanoids are no longer restricted to factories or labs, but can exist in shared human spaces, assisting in research, logistics, inspection, or hazardous environments, even if widespread adoption is still years away. And critics are correct to point out that Unitree G1 does not yet perform complex manipulation tasks with human-level dexterity, nor does it operate independently in unpredictable scenarios. But these limitations do not reduce its importance, because technological progress is incremental, and each solved problem opens the door to the next. And in this case, stable locomotion is one of the largest problems humanoid robotics has faced, and by addressing it convincingly, Unitree G1 shifts the entire field forward. And what truly separates it from earlier viral robots is consistency, as it does not rely on one impressive trick, but instead demonstrates repeatable performance across different environments, reinforcing the idea that this is not an experimental novelty but a functional platform. And this is why the question of whether Unitree G1 is the world's most advanced robot remains open but meaningful. Because even if it is not the smartest or the most autonomous, it may be the most practically advanced humanoid robot that the public can observe today, representing a transition from robotics as spectacle to robotics as applied engineering. And that transition is precisely why Unitree G1 matters, why it went viral, and why it stands as one of the clearest indicators of where humanoid robotics truly stands in the present moment.